Our next question is from GATE 2016 process calculations for 2 marks. A jacketed stir tank with a provision for heat removal is used to mix sulfuric acid and water in a steady state flow process. H2SO4 enters at a rate of 4 kg per hour at 25 degrees centigrade and H2 enters at a rate of 6 kg per hour at 10 degrees centigrade. The following data are available. Specific heat of water is this. Specific heat capacity of aqueous solution of 40% H2SO4 is given this, right? Assume the specific heat capacity to be independent of temperature, right? Based on reference of a state of H2SO4 and H2O at 25 degrees centigrade, heat of mixing for aqueous solution of 40 mass percent H2SO4 is equal to minus 650 kilojoule per kg H2SO4. If the mix, what is the situation? You can see here, this is the scenario of the question. We are adding H2O continuously at 10 degrees centigrade 6 kg per hour, right? 4 kg per hour H2SO4 is entering at 25 degrees centigrade, and you can see here the heat of reaction is given at 25 degrees centigrade. So heat of mixing will be at 25 degrees centigrade, and after that we are getting H2SO4 at 40 degrees centigrade. So you can see here, if you apply the mass balance, then you can see here 6 kg plus 4 kg is 10 kg per hour is exiting from this reactor, right? So we will apply the energy balance here. Energy balance can be given as heat in plus heat generated is equal to heat out plus heat removal, since we are removing the heat. So you can see here heat in means it is taking into the heat, how much heat it can, and giving it 4 into specific heat of this H2SO4, since it is a pure H2SO4, right, into 25 minus 25, since reaction will mixing will happen at 25 degrees centigrade and H2SO4 is already at 25 degrees centigrade, right? So you can see here, right? Now we will see another thing, how much heat it will give. Actually it is already at 10 degrees centigrade, so it will take heat from this mixture. So you can see here 6 kg per hour into 4.2 kilojoule per kg Kelvin into 10 minus 25 degrees centigrade. I am doing, please note this, 10 minus 25 I am here doing, right? You can see here 10 minus 25, it will be negative. Negative means it is taking heat from the system, right? Since I am saying here heat in, total heat in will be for how much heat it will give you and how much heat H2O will give you, but here it is already at 25 degrees centigrade, then it cannot give heat, and it is also at 10 degrees centigrade, it will take heat, not give you the heat to the system. So remember this thing, if it is 35 degrees centigrade, then it will give you some heat. If it at 40 degrees centigrade or something 30 degrees centigrade, then it will give the heat to the system, but it is not giving. So you can see here, this is the total heat in. Heat generated, how much heat will be generated? You can see here they have given one thing, they have given us that the heat of mixing for aqueous solution of 40% H2SO4 is minus 650 kilojoule per kg H2SO4. Minus sign is showing here heat is liberated, right? Heat is generated. So you can see here 650 will be multiplied by 4 kg per hour. Why I am multiplying it with 4 kg per hour? Since it is given at kilojoule per kg H2SO4, pure kg H2SO4, so it is based on the H2SO4 input, so I will multiply it with 4 kg per hour, right? So next you can see here heat out, how much heat will be out? You can see here H2SO4 will take heat since it is already at 40 degrees centigrade. So how much heat it will take? It will be 10 kg per hour 2.8 kilojoule per kg Kelvin into 40 minus 25 degree centigrade, right? It is a reference temperature, so it will take this much heat. Plus Q, heat removal rate, I am assuming here it is Q. After solving you get Q is equal to 1802 kilojoule per hour. This is the final answer. Option A is correct. Option A is correct. So thank you. Please make sure to like, share and subscribe my channel. Thank you.